So the measures of central tendency and box plots, this is something that you have probably done since you were very little. So just make sure you have the vocabulary straight. So vocabulary will be very important. My packet's going to look a little bit different than yours. So we just have to figure out, where to write things, but we'll get through it. Mean or X bar, does anybody remember what that is? Yep. So X bar is the little X with the bar above it. X bar, right? Okay, but that's the mean. So mean is just a fancy word for average. Add up the pieces of data, so how many test scores you have, you add them up. Divide by that many, right? Calculator can do it for us too. Median, what's the median? All right, when you go to find the median, it is very important that you order the data. Most of us probably will go small to big. Do I have to have things in order to do the mean?
No.
No. But when you go to do the median, you must put them in order, small to big, right? To find the middle one, you can't have the numbers scrambled up. So, order them small to big. Now, if there's an odd number of if there's an odd number of data, so like if you have 5 test scores, it's very easy to find the middle one, right? Because you cross them, like probably when you're a little kid, you cross off the biggest one, smallest one, next one, and there'll be one left in the middle. What happens if there's an even number of data? What's that? There'll be 2 in the middle. So what do you do when there are 2 in the middle?
You add them together and divide them by 2.
You find the average of those 2, right? So for instance, 1, 2, 3, 4, 5. What's the median?
3.
Now I have 2, 4, 6, 8, 10, 12. Now what's my median?
7.
So the idea is you're going to have 2 in the middle. So you have to take 6 plus 8 and divide by 2. So 6 plus 8 is 14, divided by 2 is 7. So if there's an even number or even number of data in the list, find the 2 that are sitting in the middle, add them, divide by 2. You have to take the average. Probably one of the most common mistakes is you guys will find the median without putting things in order, small to big. You just circle the one in the middle and go on. Okay, so make sure you put them in order. Mode.
Wasn't it like a number that may repeat itself in a set of data?
Most occurs the number that
Yeah.
occurs the most.
The number that occurs the most, right?
Yeah.
Now, I'm going to draw like a box plot just to show you what I'm talking about. So if you had something like this, this was 3, this was 5, this was 7. Which one occurs the most? 5, right? But in something like this, if it's What's happening there?
They're all
They're all the same, so they're, sometimes people do teach it that there's one tie, they all tie, but in that case, there isn't one that separates themselves as far as being the most. We could, oops, I switched colors. So maybe this is 3, 5, 7, 9. Now we have, in that particular piece of data, we have 2 modes maybe, right? Because 2 of them are significantly more than the others. They're occurring more often, something like that, whatever. So mean, median, mode, you've worked on that since, I think since you're little. Like I know 3rd and 4th grade math, they introduced the terms to you. You've probably done it in pre-algebra, algebra, now you're seeing it again in algebra 2. Range. What's the range when you look at a data set?
The biggest number minus the smallest number.
Max minus min. You take the maximum number minus the minimum number. Now, do I have to have them put in order for that?
Yes.
No,
not all.
but I can, if you are not, you know, there are some kids out there, you guys are gonna try to do this stuff so fast that you don't wanna take the time to put it in order. I totally get that. But you better be careful that when you look at that list, that there isn't, you know, some maximum or minimum hiding in the middle that you forget to write down, right? So I think the most important, if you do things by hand, you just put it in order from the beginning. 5-number summary. What's a 5-number summary? Minimum. Five-number summary also give you a maximum. It'll give you a median. Nope. Q1 and Q3, right? So 5-number summary. So I'm going to jump down to the box and whiskers plot. Because a 5-number summary can also be seen when you do the box and whiskers plot, right? So you'd have your minimum here, your maximum out here, your median is this middle number, Q1, Q3. When we get into 5-number summaries, a lot of times you can do them by hand. The calculator will also do them for you. Interquartile range. So the median splits your numbers in half, but then when you look at Q1s and Q3s, those are splitting the upper 50% in half also, right? And then Q1 would be splitting the bottom half of the numbers in half again. So really now it is 25% here, 25% here, 25% there, 25% there. So it splits it up into 4 equal chunks. Now they're not always spaced equally, but they have 25% of the data in every space, if you will. And to find Q1s and Q3s, you do medians. It's just like taking just the numbers at the top and do a median. Take the numbers at the bottom and do a median. So you follow the same rules up above. Yep, good. IQR. Does anybody remember IQR?
Isn't that the difference between Q3 and Q1?
It is. IQR is what we call the interquartile range. So interquartile is what's in the box, right? So what's in the box? So that is Q3 minus Q1. or simply the range of the box? So what are the numbers from the top of the box to the bottom of the box? You guys have a picture of symmetric and skewed data. Um, So let's just think, like if I do salaries in my neighborhood, if you have, 50,000, 70,000, 80,000, 90,000, and then I used to do the example, like 1.2 million, back when Kevin Garnett used to live in the area. So you throw Kevin Garnett in there, right? He's your neighbor. He was actually, at the time when he left, I think he was at 15 million. So what is that going to do to our data, right? So we're going to have a minimum and the median, right? So 50,000 is the minimum. What's the median? The median is at 80,000. But then all of a sudden, the IQR would be about right there. But then we have this, right? So when you see this, what happens to the average when somebody like Kevin Garnett lives in the neighborhood? 15 million. Because without him in there, the average, is $75,000. Now Kevin Garnett lives in the neighborhood. What happens to the average? Literally, somebody calculate that for me. What's the average? 50,000 plus 70,000 plus 80,000 plus 90,000 plus 15 million. I guess I can do it too. 50 plus 70 plus 80 plus 90 plus 15, 1, 2, 3, 1, 2, 3. Divide by 5.
3,058,000.
3,058,000. That's the average salary of my neighborhood all of a sudden because Kevin Garnett lives there. I won't make 3 million in my career. Right? So see how that works? Which way did our data get skewed? To the right. So this is skewed to the right. What term do we give that? 15 million. The outliers, that's the next term on your graph. So when you look at those boxes that they're doing, one has got a symmetric, right? One is symmetric data. Things are spaced fairly even. Skewed right, that's when the data gets pulled one direction or another, and it always skews towards the outliers. So any questions? All right, I gotta find. All right, so we skipped over a term called standard deviation, so we need to go back there. Basically, a standard deviation is a number that measures the spread from center. So when you guys take standardized exams, ACTs, SATs, whatever, we can take the data and there's data for, you know, maybe there's Hopkins High School, then there's data for everybody in the world that takes an ACT exam. So standard deviation would kind of help us determine where you're located versus the center, the mean of the data. And we'll talk more about that.
Is that like the range? Like, is this similar to the range?
No, the standard deviation though, like, if I have a number for my standard deviation, like you guys take a test for me, and that number gets really large, like we took a 50-point test, and I calculated a standard deviation of 10 points, that means from the average, my students are so spread out. So we can move 3 standard deviations away from the mean. It would tell me that my test probably was not very good, or you guys are, your ability ranges are so spread out. But when they get really tight grouped, that everyone's kind of in the same area. Well, we can talk more about it. We don't do that, the standard deviation, but on your calculator, you'd be looking for the S sub X, which means the sample standard deviation. Anything else on your packet that we need to get down? Outliers. I do want to talk about outliers very quickly, so to determine an outlier, we are going to use a 1.5 times the IQR rule. And people will determine how to find an outlier in different ways at times. So you may go off to college one day and take a statistics course and you'll find that they use different rules. So this is a pretty simplistic way of calculating an outlier. So 1.5 times the IQR. So what you're going to do is you would have a box and whiskers plot thing going on. The idea is the IQR is what's in the box, right? Then when you multiply by 1.5, you get the same amount of what's in the box, right? So there's 50% of my numbers are here. By multiplying by 1.5, I have that same 50% plus half as much. And what you're going to do is you're going to add that 1.5 IQR from the top of the box, and you're going to subtract 1.5 IQR from the bottom of the box. Anything that's outside of those two numbers would be considered an outlier. Anything outside those two numbers is considered an outlier. So if you went back to the Kevin Garnett situation, our IQR would be somewhere around $20,000, you know, if you took the top Q3 minus the Q1. Even if I take 1.5 of that, you know, his salary would be well outside the range, so it would be considered an outlier. Any questions, comments, concerns? So we have a couple examples that we'll go through. I'll start a new video for that.